Let's move on to filling the world with objects and start with vegetation. In order to place forests in certain areas, these mostly green ones, we need a map of these areas, a mask. The land cover classification map is usually used for this purpose, with colors corresponding to certain cover types. A fixed legend is often used to match colors and land cover types when developing classification maps. Such a map is available in the Georeference Terrain Generation Asset Pack. Create a new mask layer called Vegetation and add the texture from the land cover folder. This map doesn't require a high level of detail. Click on the texture to adjust its settings. You can also adjust the boundaries for the layer. We'll leave these unchanged to use the whole map. Here we need to extract the desired regions of the map. They can do it via different types of filters. Let's take a look at them. The index type is available only for images with indexed colors. Land cover maps most often use the indexed colors, so this is the most natural way to select areas that you need. Select the range of colors in the From and To fields. Now only pixels with the matching colors will get into the mask. Multiple ranges can be specified. The single channel filter enables you to treat a whole channel of the image as a mask. Here the green channel fits best. The third filter type, color, can be used if you don't have a land cover map, but only information about the surface color, albedo. You can add as many sources as you want in the sources section, and they will all be combined into a single terrain mask. Let's add some imagery textures. Select one of the sources and apply the color filter. You can set the desired color manually or pick a value from the viewport. You may also need to increase the range of color values to include close colors and make the mask smoother. You can also add multiple color filters. There's no need to repeat the same for the remaining layers. Just click Copy and select the layers that will be assigned with the same filters. Let's go back to the land cover map and adjust filters to use the indexed colors. Let's create a mask. You can adjust sources and their settings anytime, even after creating the layer. TMS sources can also be used as source textures. Let's add another mask with a color filter. You can add as many masks as you want, but only 20 will be generated for landscape terrain. After regenerating the terrain, you won't notice any changes because masks are auxiliary terrain components, usually invisible. Go to Helpers, Show Landscape Data, to see the terrain components including the 20 masks. Here we can see 2 masks generated according to our data. Terrain masks can be used to add details to the terrain surface. Check out the Landscape Terrain video tutorial to learn more about configuring details. Masks can also be used to define scattering areas for geometry. And that's what we are going to do for vegetation. To place trees, grass, or anything else on the terrain, you need to prepare template objects. The Georeference Terrain Generation assets include ready-to-use examples for spruce and pine and a grass object. You can find them in the Nodes Vegetation folder. To create your own template object for trees, create a mesh clutter object based on an existing model of a tree. Clutter objects serve for random scattering of identical meshes within their bounds. Customize materials and visibility distances for the levels of detail. Simply configure its settings as required. Density of trees, spread of random size and rotation. To align the trees with the terrain surface, make sure to enable the intersection flag. This ensures that all vegetation will be placed accurately after generation in Sandworm. Clutter objects are added as terrain's children. When your scene contains thousands and millions of trees, for optimization purposes it is recommended to limit the visibility distance of polygon trees. 100 meters is quite enough, and display imposters further away from the camera. Imposters are textured planes that mimic polygon meshes visually and significantly reduce the complexity of the scene. Open the Imposters Creator tool, The default settings are appropriate for vegetation imposters, and click Create while having the mesh clutter object selected. Next, specify a folder to keep the generated textures and materials, and the tool will do the rest. It will take snapshots of the source mesh from different angles and create a new object containing imposters placed at the same locations as the original meshes. Also, adjust the minimum visibility distance for imposters so that they become visible when the original meshes are hidden without overlapping. That is 100 meters as we said before. Imposters now substitute meshes as the camera moves away from them. You can also adjust the fade distances and the surface settings for smoother transition. For that, you need to turn on the LOD Smooth Fading feature. For more details, watch our video tutorial on configuring levels of detail. Now let's give appropriate names to the configured objects and save them as node references by dragging each node to the asset browser window. Thus, we get assets ready for use in Sandworm. We don't need these nodes anymore, so we delete them. The asset pack already includes the same prepared node references. And as for grass, UNIGINE has a dedicated object providing optimized rendering of multiple textured quads similarly to imposters. When creating a template object for grass, you should enable the intersection option and adjust distribution parameters of grass chunks. You should also take into consideration the relationship between the diffuse texture of the grass material and the num textures and mass texture parameters. The number of rows and columns in the diffuse texture must correspond to the chosen number of grass variations and the number of channels in the mass texture. Now, save the node as a node reference and it's done. Go to the Sandworm project and take a look at the objects panel intended for typical procedural generation tasks like placing objects along splines and generating buildings. Here, you can add vector data sources. Add a new vegetation object. Mostly it is used for plants, but it can randomly scatter any objects across the terrain surface according to a mask. It supports grass, mesh clutter, for example for trees, and world clutter, for complex objects made of several parts. The latter has limited support and falls beyond the scope of this tutorial. In the parameters, specify object name, mask for vegetation, and the prepared node reference with a tree. The last split length parameter is technical. The mesh clutter, world clutter, and grass objects use float precision of coordinates internally. If the size of the area they cover is large enough, positioning errors and artifacts at distances of more than 10 kilometers from the object's pivot point are likely to occur. The split length value defines the size of the grid into which these objects will be split to avoid errors. Lower values result in generation of more vegetation objects, which increases the overall rendering load, so it is worth leaving the default value. Configure objects for trees and their imposters. Let's use the second mask for the second type of trees and add an object for grass as well. Click Generate and wait for the result. Now, the landscape has vegetation and does not look like a desert. New nodes are available in the Vegetation Child mode. As you can see, the pine nodes were divided into 4 sections. Since the size of the central area is not that big, but the spruce nodes, placed across the second mask of a larger size, are divided into much more sections. Please note that the vegetation objects use asynchronous generation of instances, which may be noticeable when the camera moves too fast. You can fine-tune settings for asynchronous data streaming in the landscape section as well as in the grass and mesh clutter nodes themselves. Use SSD disks with the maximum bandwidth to eliminate such problems. Check out RAS optimization and vegetation offering tips in our documentation.